So as we all know, there are a number of human activities that are endangering the livelihoods of future generations. We are facing a number of very significant challenges, both social and environmental. Things like ending extreme poverty, hunger, the need for sustainable and clean sources of energy, and taking climate action. Now, these are just 4 of a longer list of sustainable development goals that were set out by the United Nations earlier towards the end of 2015 as some of the most important challenges that we're faced with as a society today. Now, these problems are really important, but they're also very hard. And one of the reasons is that all these problems, in one way or another, they deal with some very complex processes and systems that sort of occur at a global scale, of many components that are interconnected, interdependent. And what this means is that it's very difficult to build models that we can use to make predictions about the future and inform decision making. Now, on the positive side, we are in the middle of a sensing revolution. Sensing technologies are becoming cheaper and cheaper. Think about the kind of capabilities that you have on your smartphones. Satellites are becoming cheaper and more accurate. And we're just getting access to a whole new set of data streams, unconventional data streams like social media data or crowdsourcing data. Now, all these new data sets that are becoming available in conjunction with new techniques from computer science that make it possible to process very large data sets in an inexpensive way are creating some huge opportunities for applying these new technological developments and help in finding new solutions for these very important societal problems. And in this space, AI, artificial intelligence techniques, will have to play a key role. A lot of these data sets are very unstructured, they're very complex, so we're going to need to use AI techniques to actually make sense of them, to actually understand them, and build models that we can use to come up with good predictions about the future and support decision making. So in my group, we've been doing a lot of work in this space, and for this talk, I will focus on one particular project that I'm particularly excited about. So one of the biggest challenges in the context of poverty mitigation is that we don't have good poverty data. So this, I'm showing here a map of the African continent, where I'm showing the availability of survey data for several countries. And this is the availability in the past decade. And you can see that many countries are white. And what this means is that we don't have any survey data available for that country in the past decade. And as you can imagine, this is really problematic. It's very hard to, for example, measure progress. How well are we doing towards this goal of eliminating poverty? It's very hard to figure out whether policies are working or not, and so forth. So one of the things that we have been trying to do is to see whether we can use all these new unconventional, passively collected, cheap data sources to estimate poverty in developing countries. So in particular, we've been looking at remote sensing, so high-resolution satellite images, because it's becoming more and more affordable and accurate. Like these days, you can get high-resolution videos from space, like the one you can see on the left, and this is available commercially today. And as you can imagine, there is a lot of information in these videos, in these images. And the challenge is really how to extract this information in a meaningful way. And this is where artificial intelligence comes in. We can use AI techniques, the kind of techniques that Fei was talking about, to actually inspect these images and make inferences, understand what is going on, and make inferences about things we might care about, like agricultural yields or deforestation, or try to estimate economic indicators, like in the case of poverty. So what we did is we developed a machine learning model that takes as input high-resolution satellite images and is able to estimate average household expenditures in an area or assets-based measures of wealth. And the model essentially looks for patterns in the images, things like roofing materials or infrastructure or other features of the landscape that are predictive of poverty. As you can see on the right, the estimates that we get from the model are very accurate, especially for household assets. And the key feature of this is that it only requires high-resolution satellite images to do this. So what this means is that we can very inexpensively generate very high-resolution poverty maps for entire countries or continents. So here, for example, you can see the poverty map that we generated for Uganda with about 500,000 images. And you can see on the left the maps that we get. They're very close to the most up-to-date map that we have on the right. So most of the poverty is kind of in the north of the country, where it's more towards red. So this is very exciting. There are a lot of potential applications for these ideas. We've been talking to NGOs. We've also been talking to the World Bank. There is a group there that has been looking at drafting a new constitution for Somalia. And one of the challenges there is that there is absolutely no data for that country, and you cannot send people there to actually collect some on the ground because it's too dangerous. And so we're very excited to see what they can do with this type of data in that context. So if you want to know more about this, we have a few technical papers. There is also a very interesting article on the New York Times that was written by a leading Harvard economist, a leading expert on poverty. It's very accessible, so if you're interested in learning more, I suggest you to take a look at that. So more recently, we've also been looking at using these models to estimate crop yields, also from cheap and expensive sources of data. This is a very important problem because we know that there's going to be 2 billion people more to feed by 2050, and we know that information technologies will have to play a role. Another project that we did was to actually show how we can use AI techniques to improve decision-making in agriculture and improve agricultural yield. We actually won a competition that was organized by Syngenta, which is one of the leading agrochemical companies in the world. So to conclude, as we've heard, there are a number of concerns about the threats that new and more powerful AI techniques pose to the future of humanity. I think we can also take a more optimistic view. These new recent advancements of AI also creates huge opportunities for having very beneficial impact on society in fields like healthcare, education, and sustainability. Thank you.